So this next chapter has to do with rational functions, and what we think of when we think of rational is probably the idea of a rational number. And just so we're clear on that, the idea of a rational number is a fraction. It's any number that can be expressed as a fraction. So what is a rational function? A rational function is a function that you can express as a fraction of two expressions. So we have a fraction with two different expressions in it. Now, they don't have to be variables, as you're going to see with the very first one, but it's got to have an expression in it, okay? Because those are the ones that are unique to look at. So a rational function is a function that has a variable expression in either the numerator or the denominator. And what we're going to talk about is how they behave, and particularly the domain. So what we're going to talk about specifically first is the domain of a rational function. So if you look at this first function, it says that we have 1 over x. And remember, the domain is all x values you can use. So we have to look at this and say, what x values can I use in this function? Well, I'm taking 1 divided by x. So really, what you're doing is taking 1 divided by any number. So the question is, can you not divide 1 by some number? Well, you can't divide by 0. So this number can't be 0. So in terms of a domain, x can't be equal to 0. Now we just need to figure out what exactly it looks like near this excluded value. So let's take a look at some values on a table. Oops. So let's take a look at some values here on this table and see what happens. So if I take a number and 1 divided by that, it's another way for saying the reciprocal of it. So if I take 1 divided by 1, I'm going to get 1. If I take 1 divided by 2, I get 1/2. If I take 1 divided by 3, I get 1/3. If I take 1 divided by 10, I get 1/10. So if you look at this graph, what seems to be happening is I have a point here, then here, then here, and it's going closer and closer to the x-axis. Now let's suppose I picked smaller numbers. 1/2. If I take 1 divided by 1/2, it's the same thing as taking 1 timesing by 2. So that's going to be 2. So if I look at the graph here, it's going to be here. If I take 1 divided by 1/3, I get 3. So this graph is going up, but I can't have it equal 0. So I can't have a value at 0. So I'm going to just stop at 0 and just put a big X through that, because that doesn't work. But what seems to happen is we get this line. It's going this way. It's getting closer and closer to the x-axis. And this line is going to keep going up. Because when you divide by a number closer and closer to 0, you're going to get a number that keeps going up and up. Now, I haven't finished my graph yet, but let's take a look at something here just for a second. Let's take a look at x when it's -1. When it's -1, y is also going to be -1. When x is a -1/2, y is going to be -2. When x is equal to a -1/10, y is going to be equal to a -10. So what's happening on this side is it appears to be a reflection across the origin. So it looks something like this. So what's happening with this graph? Well, as x goes to infinity, so as x gets bigger, what's happening to y? Well, y is going towards the x-axis. So it's going towards 0. It's not going to reach it, but we know that. Okay? But what's interesting is what's happening as we get closer and closer to 0, because that value doesn't exist because you can't plug 0 in here. So what I should be talking about is as x goes to 0. Well, we have two different scenarios. As x goes to 0 from this side, it's going up. As x goes to 0 from this side, it's going down. So as x goes to 0, y is going to infinity. But on this side, as x goes to 0, y is going to -infinity. So what you need to do is you need to analyze what's happening at a specific excluded x value and see via a table or something how it behaves because of the nature of not including that value. Now I'm going to jump to how to find specifically what are called asymptotes. And what asymptotes are specific lines that a graph never reaches. So what do I mean by a line that a graph never reaches? Well, if we look at this previous graph, you can see that this line never hits the y-axis or the x-axis. Those are lines that the graph never seems to reach. Okay? And when you talk about lines that a graph never reaches, those are called asymptotes. And the way that you find those, they can be fairly complicated if you don't know what to do, but to try and simplify it very quickly for you, in terms of vertical asymptotes, vertical asymptotes happen for the sake of you want you want this to get a value back that doesn't exist. So the only place that happens that you don't get answers that exist is where the denominator is 0. Okay? So find out where the denominator is equal to 0 and you get the vertical asymptotes. Horizontal is a little bit trickier. Horizontal is dependent on a few things, okay? Horizontal is dependent upon the degree in the numerator and the degree in the denominator. Okay? So what you need to know is if the degree in the numerator is bigger, so if the degree in the numerator is bigger, there is none. Okay? There is no horizontal asymptote if the degree in the numerator is bigger. If the degree in the denominator is bigger, then the line y equals 0 is your horizontal asymptote. Okay. Lastly, this one is a little bit different. So what happens if the degrees are the same? Okay? If the degrees are equal, then the way that you write this for the horizontal asymptote is y equals the leading coefficient divided by the leading coefficient. So let's talk about this first one, and then I'm going to stop here and I'm going to talk about how you do this with these two examples in the next video.